back to our channel Learn with Harshit. So from now onward we are going to learn tricks in rotational dynamics. This is the part 1 of this video, and today we are encountering the topic opposing forces trick, and we can, after watching this video until you are able to find the explanation of the sum of the systems, or you can say block, in very short period of time. And this chapter name is rotational dynamics, so don't take it easy. This chapter is a little bit hard, but don't worry, I come up with too much tricks in this chapter so that you can solve your question in very short period of time. Now, what is the trick? So the trick is simply the acceleration A. Whenever you have to find the acceleration of a body, you can simply find it by using the trick that it is equals to the difference of opposing forces divided by the total mass of the system. So whenever you have to ask what is the acceleration of the system, you simply find the difference of opposing forces and divide it with the total mass of the system, and you got your answer as acceleration. Now, first of all, what is opposing forces? Before going to the solution and before going to show you some example, let's understand what opposing forces is. So when two or more than two forces in which one is along the direction of acceleration and another one is opposite to the direction of acceleration called opposing forces. So basically I'm trying to see you whenever you can see the forces where one forces is along the direction of motion and another forces is opposite to the direction of motion. So these type of combination of forces are called opposing force. Let's understand clearly it with a figure. So here you can clearly see the figure where two blocks, one have mass capital M and another one have mass small m, and also you can suppose that the block of mass capital M will be greater than the block of mass small m by weight. Now what happens then? Simply the block of mass capital M will go downward. I'm supposing that it will go downward with certain acceleration A, and the block of mass small m also go in some direction, not some direction, it will go in positive x direction with certain acceleration A, because this will be a pulley and this will go downward, so it will by genuinely go to the positive x direction. Now what happens to the block of mass capital M? It will go just because due to some forces acting on it, and I'm supposing the forces will act over the block of mass capital M will be F2, going downward direction. Now what happens to the block of mass small m? The forces acting on this block will be to the backward direction, or you can say in the negative x direction, because the because the acceleration of this block is towards the positive x direction. So the force I'm supposing will be the F1 that is acting towards its uh, negative x direction. Now what is the F1 and F2 here? The F1 and F2 here are the opposing forces, because you can clearly see these are the forces which are the opposing forces, or you can say opposing the direction of motion. So in our case F1 and F2 are the opposing forces. So whenever you want to ask what is the acceleration of the system, you simply use difference of opposing forces divided by the total mass of the system. So acceleration E is what? F2 minus of F1, because F2 and F1 are the opposing forces, so it will become F2 minus F1, dividing it with the total mass of the system. So here what is the total mass of the system? It will be m plus a small m, which is equal to m plus a small m. So the acceleration of the system will be F2 minus F1 divided by m plus m. So I'm hoping that you will understand what is the opposing forces is. Now come to see some solved problem. So here you got some solved problem. So the problem is two block of mass small m and capital M. Here you can see the two block, which one we have mass small m and another one have mass capital M, are attached to the string passing through a pulley of radius r and moment of inertia I. So you can see these are attached to a string which is connected to a pulley which have some radius r and moment of inertia I. The block of mass m slides on a smooth horizontal surface while a block of mass m hangs. And this question says the block which have mass capital M will hanging on the floor, and the block which have mass small m will sliding on the floor. Now the acceleration of the block of mass capital M is, so the question want to know what is the acceleration of this block, that is the block which have mass capital M. One thing you also notice, they say that the mass small m slides on a smooth horizontal surface. So the block which have mass small m is simply sliding on a floor which is frictionless. We can also note that point because will be useful in our question. Now before going to the trick, I want to show you the general method of solving this question. So here you got the general method of solving this question. To solve this question, what you have to do first, you have to simply find the free body diagram of each of the blocks, that is block of mass small m, block of mass capital M, as well as this pulley, because in the question it is given that this pulley is not massless, not frictionless. This pulley have some radius r and moment of inertia I, so that it will must have some mass. So I'm not assuming that this pulley is massless. So you have to calculate the free body diagram of this pulley as well. Now let's look the free body diagram of capital M. So what is that? It is the downward force mg acting over it. Tension on the both string will be different just because this pulley is not massless. So I'm supposing the tension on the string connected to the block of mass capital M will be T1, and the tension to the string connected to the block of mass small m will be T2. Now the free body diagrams of capital M will be like that: mg minus of T1 is equals to ma, and the free body diagram of block of mass small m will be T2 is equal to ma, just because there will be no friction force acting on the block of mass small m, so there will be no backward force or opposing forces on the block of mass m, so it will simply become T2 is equal to ma. Now free body diagram of you have to find free body diagram of this pulley. It will become T1 minus T2 is equal to Ia by R square. I know you will confuse why this happens, so if you want to know why this happens, then comment in the comment section. I will come up with a video in which I illustrate why you can use this formula. Now understand, simply you can know one thing: because this pulley have some mass, so the forces, net forces acting over this will be only T1 and T2, that is the tension in the string. So it will in the direction of escalations toward toward T1. So T1 become positive and T2 become negative. It will become T1 minus T2, which is equals to ma. And since I is equal to mr square, when changing this we got Ia by R square. And if you want to know the further more about this, then please do comment in the comment section. I come up with a video. Now adding these three equations, you got the acceleration as mg divided by capital M plus small m plus I by R square. So are you really serious to solve this question via general method? And if you, then you must have too much time. So are you really serious to use general method in this question? I'm supposing not, because let's show you the advantage of using trick in this method. So here is the question again: that the two blocks of mass small m and capital M are attached to a string passing through a pulley of radius r and moment of inertia I. The block of mass small m slides on a smooth horizontal surface, while a block of mass capital M hangs. The acceleration of the block of mass capital M is. So let's see what does the trick says. The trick says the acceleration A is simply the difference of opposing force divided by the total mass of the system. Here you can see the total mass of the system. So this is the trick, and this is the figure as already earlier. Now first of all, first things comes first, we have to find the accelerations direction. So here I can supposing that the direction of escalations towards downward in case of capital M, and in case of a small m the direction of toward positive x direction. And similarly the forces acting on the capital M will be the mg, the weight of the body, and the force acting on the block of mass small m will be 0, because this block of a small mass sliding on a smooth horizontal surface, so that this surface will be frictionless, so the friction force will be 0 over it. So what is the acceleration A? The acceleration is simply becomes mg minus of 0, because there will be no opposing forces acting on block of mass small m, so it will become simply mg minus 0 divided by the total mass of the system. The total mass of the system is small m plus capital M plus I by R squared. So where should this I by R squared come? As we all know, this pulley is have some radius R and moment of inertia I, and it will rotating. So it will have some moment of inertia as given in question, and I'm supposing that it will m dash R square, and moment of inertia will be m dash R square, and m dash is the mass of pulley. So after substituting the value, we got m dash is equal to I by R square. And since the trick says it is the total mass of the system, so the total mass of the system must include capital M, small m, as well as the mass of the pulley. So it will become mg divided by m plus I by R square. Hey, are you match the answer with general method? The answer is yes, you matched the answer. Why it happened? You can take less than you can say 1 minute to solve this question. Then why should you go with the general method? You should go definitely with this tricky method to find the acceleration of the system. Now let's see some another solved problem. Here you see the problem. Consider the figure given. One end of the string is connected to the block of mass small m. So here you can see the figure where one end of the block of mass small m connected to the string, which is falling down. So here you can see this is falling down with certain acceleration A, while the other end of the string is wounded round on the pulley of radius r and the moment of inertia I. Here you can see it is connected to a pulley which have wounded the string, and it is rotating with some moment of inertia I. The smaller pulley is massless, and this smaller pulley has some no mass in it. The acceleration of the block is, so they want to ask us what is the acceleration of the block. So what you can do, you can use the trick, that is a is equals to mg minus 0 divided by m plus I by r square. What is the trick? The trick is a is equals to difference of opposing forces divided by the total mass of the system. So here you can see only one opposing force, which is mg, acting toward it, and since the total mass of the system is m plus I by r square, where this I by r square come, because this pulley given in question have some what you can say moment of inertia, so it will rotating and have some moment of inertia I, and I is equals to mr square. After substituting the value, we got m dash is equals to I by r square. So I'm putting this value in this and got the total mass of the system. And also the question is already mentioned that this smaller pulley have no masses, no mass, and you can see this is massless, so I'm not calculating the mass of this. I'm simply calculating the mass of the block and the mass of the big pulley. And after substituting this value, we got our expression as mg divided by m plus I by r square. Wow, it will take less than 30 seconds to solve the question. Are you? And if I show you the general method, you will seriously get some headache. So I'm hoping that you will solve this question, these type of questions by using tricky method. Now here you can see some practice problem for you. This question is recently asked question in JEE Main 2020. So the question is, a uniformly thick wheel with moment of inertia I and radius r is free to rotate about its center of mass. See figure. So here you can see the figure where you can see some a pulley which have moment of inertia I, and the two blocks which have one have mass m1 and one have mass m2, one with go with force downward in m1g and one with m2g. A massless string is strapped over the rim and two blocks masses m1 and m2, where m1 is greater than m2. So it is mentioned that m1 is greater than m2, so this will definitely go downward toward the m1 direction. Are attached to the end of the string. The system is released from the rest, the angular speed of the wheel, when m1 descends through a distance h. So they ask us what is the angular speed of the wheel, that is the pulley, when this m1 travels some distance h. So I have encouraged you to solve this question on your own and comment the answer in the comment section. And if you do not, and I can provide you the answer of this question in the upcoming lecture. So thanks for watching this video. Don't forget to like, share, and subscribe to my channel. If you like the content, then do not forget to like, share, and subscribe. Thanks once again.